Lesson 2.11, Sketching Modulus Functions, A-Level Pure Maths, Year 2. In this lesson, we are going to learn how to sketch modulus functions. The modulus, or absolute value of a number, p, is written as this. So you have the p placed between two vertical bars. Sometimes it's also written like this. And this is a positive numerical value of p, which means that even if p is negative, once p is put into this symbol here, the value becomes positive. So let's see some examples. So we've got the modulus of 7 is going to be 7, and the modulus of minus 7 is 7. And that's exactly what happens when you put a negative number into the modulus symbol. So this means that whatever goes into this symbol comes out as positive. So in general, a modulus function is given by y is equals to the modulus of f of x. This lesson will concentrate on the sketching of modulus graphs. In a subsequent lesson, we're going to learn how to solve equations involving modulus functions. But this lesson will be dedicated to just sketching. Now, before we go into sketching, we're going to do an elaborate drawing of two functions, just to see the nature of the functions. So the first one is the graph of the modulus of x minus 1. So we are going to draw a table and put in some values and find the corresponding y values. So we draw a table and put in the following x values from minus 3 to 3. So when I put minus 3 in place of x, I'll get minus 3 minus 1, which is equal to minus 4. But the modulus of minus 4 is 4. So I get 4 over here. Similarly, if I put minus 2 here, I'll have minus 2 minus 1 will give me minus 3, but the modulus of minus 3 is 3. So I get 3 here. And so will I get 2 here, and then the following values for the rest. Then if I plot these points on a graph, I'll get the following graph. So as you can see, when x is minus 3, we get y to be 4. When x is minus 2, y is equal to 3, as shown here. And then for this point here, when x is 3, over here, y is 2. And so that's the graph we get. So generally, we get a V shape like this one. The next graph we're going to draw is y is equals to minus the modulus of x minus 1. Please note that the negative is not into the modulus sign. This is outside the modulus sign. So geometrically, the graph of this will be a reflection of this graph in the x-axis. We learned from year 1 that when you have a function f of x, then minus f of x will be the reflection of this graph in the x-axis. So let's see what happens when we plot this. So again, we draw a table and put the same values in and find the corresponding y values. So when I put minus 3 here, minus 3 minus 1 is taking minus 4. The modulus of minus 4 is 4. And I will negate it because of this negative sign here. So I'll end up with negative 4 here. And when x is minus 2 minus 1 is minus 3. But the modulus of minus 3 is 3. If I negate it, I'll get minus 3. So I'll get that. If I do the same thing for the rest of the x values, I'll get the following values. When I plot these points, I'll get the following. And that's exactly what we expected, because this graph is a reflection of this graph in the x-axis. Now, in exam questions, if you are told to sketch a function like this process here is exactly what you are not supposed to do. If you do this, you either lose marks or you not get a mark, because this is not a sketch, this is a drawing. I just drew this for you to see the nature of the respective graphs. So let's proceed and do some sketching. So there are two methods I'm going to show you. The first one I'll call sketch and reflect. So here, sketch a straight line and reflect some part of the curve. The next one is what I will call the vertex method. So we'll answer 4 questions in this slide using both methods. So first one is y is equals to the modulus of 2x minus 6. So we'll first deal with the sketch and reflect method. let's draw our axis. And then for this equation, what you do is remove the modulo sign and sketch this straight line. And as you can see, the y-intercept is -6, the gradient is positive, and then the x-intercept is 3. And so when you sketch this, you're going to get this graph here, where this is the y-intercept and this is the x-intercept. But because of the modulus function, no part of this curve here should have a negative value. But as you can see, this dashed line, part of the curve, have negative values. So we're going to reflect this part of the curve in the x-axis, and that means this point here will be over there, and so the y-intercept of the sketch will be +6. So if I reflect it, I'll get this, and that is the sketch required for this modulus function. Now the vertex method for this same function, and that's my preferred method. So we draw our axis. And generally when we have a modulus function given by y is equals to mx plus c plus d outside the modulus function, we don't treat d as part of the modulus function because it's outside the modulus function. And then for the vertex method, we are going to factorize the m out and make sure you factorize a positive value out of the modulus function. You will never factorize a negative value out. When you do that, you change the whole question. And you see examples very soon. So when m comes up, I have the following. M, and then we have x here, and then plus c over m. And then the d is over there. And so once you've done that, the vertex is given by the negative c over m for x coordinate, and then d for the y coordinate. So the vertex you're looking for will be minus c over m d. Just make sure that when you're doing the factorization here, the coefficient of the x is always 1. And then you have that as your vertex. So let's go and apply this method to this modulus function. So what I have is y is equals to 2x minus 6. If I factorize 2 out, I'll get the following. I have x here, and like I said, the coefficient of x is 1, and I have minus 3 here. So if I negate minus 3, I'll get 3, and the value of d outside here is 0, and so my vertex is 3, 0. Then I'll indicate a point on the graph, and then from there I'll draw a V-shape with its vertex at 3, 0. So I'll get the following. And then you have to find where the graph cuts the y-axis, the y-intercept. And the y-intercept occurs when x is 0. So when x is 0, I have 2 times 0 is 0, and I have minus 6 left in the modulus sign. So I've got mod minus 6. But the modulus of minus 6 is 6. And so my y-intercept will be 6. And then I can indicate it on the graph. And that is how you use the vertex method. We're going to solve 3 more questions using the 2 methods. So here, I'll draw my axis. And then I've got y is equal to 2x plus 6. I remove the sign to get the following. And then I'll draw our sketches, and I can see that I've got a y-intercept of 6, and then an x-intercept of minus 3. So I'll sketch it, and this is what I get. And then I've got 6 over there as the y-intercept, and minus 3 here as the x-intercept. But no part of the curve must be negative. So this dash part must be reflected in the x-axis to get this one. And that is the graph required. For the vertex method, for the same modulus function over here. So first, I've got this. I'll factorize the 2 out to get the following. And I've got the coefficient of x here to be 1. So now I can negate 3. And then the value for d here is 0. And so my vertex will be minus 3, 0. So if I indicate that on the graph, and draw a V shape with that as vertex, I'm going to get that. And this V shape is this way because the coefficient of the modulus function is positive. Now we need to find the y-intercept over here. And that we can get by substituting x to equals to 0, because the y-intercept occurs when x equals to 0. So when x equals to 0 over here, 2 times 0 is 0. So I'm left with plus 6 in the modulus sign, and the modulus of 6 is still 6. And so the y-intercept is 0, 6. And then I need to indicate it on the graph. And I'll get this, which is the same as using this method. Next question. Y is equals to the modulus of minus 2x plus 6. So I've got my axis drawn. Then I've got this question to do. Y is equals to minus 2x plus 6. All of that in the modulus sign. So if I remove the modulus sign, I'm going to get y is equals to minus 2x plus 6. And so I'm going to sketch this curve. And we can see that it has got a gradient of minus 2, which means it will slope that way. And a y-intercept of 6. And then x-intercept of 3. So this will be the graph where the y-intercept is 6 and the x-intercept is 3. But again, this dash part cannot be part of the curve because it has got negative y values. So we'll reflect this part in the x-axis to get this. And that is our graph. Now for the vertex method, I've got my axis and then I've got this to sketch. And so I'll bring 2 out, not minus 2. I'll bring 2 out. If you bring minus 2 out, then the whole question is changed. And that will affect the geometrical shape of the curve. So we bring positive 2 out. And when I do that, I get this. But the coefficient of x must be positive. And so we can factorize minus 1 outside the brackets inside the modulus sign to get it. Now the modulus of anything negative is positive. And so we can write this one as this. Because what is inside here is negative, but the modulus is positive. So now that I've got that, I can see that coefficient of x is 1. And so this is the time I can negate minus 3 to get 3. And because the d over here is 0, my vertex is 3, 0. Then I'll indicate it on the graph and draw my V shape with this point as vertex. And so I get that. But we need the y-intercept over here. The y-intercept occurs when x is 0. So when x is 0 over here, I have minus 2 times 0. That's 0. And so I'm left with 6 in the modulus sign. The modulus of 6 is 6. And so the intercept here is 6. So you will have noticed that the graph of this and this are the same. And this is because of this analysis that I've done here. We started with this one here, and then we end up with this, which is the same as this, and hence that one. And that's the reason why these two graphs are the same. So next, we have y is equals to minus 2x minus 6. For the sketch and reflect method, I've got my axis, and then I've got y is equals to minus 2x minus 6. If I remove the modulo sign, I'll be left with y is equals to minus 2x minus 6. Now, this curve has negative gradient and a y-intercept of minus 6. It also has an x-intercept of minus 3. So we can sketch that to get the following, where the y-intercept is minus 6 and the x-intercept is minus 3. But again, this part of the curve must be reflected because it has negative y values. If you do the reflection, at this point over there, we should be plus 6. And so we get that. And that's our curve. Now let's use the vertex method for this one. So I've got my axis and I've got this to deal with. Remember, we need to bring a positive 2 out. So when 2 comes out, I've got that. But the coefficient of the x must be positive. So I can factorize minus 1 out, and it must remain in the modulo sign. And so I'll get this. But what's the modulo sign is negative. We can rewrite this one as this, because the modulo sign will get rid of this negative sign over here, and I get that. So now that I've got that, the coefficient here is 1. I can negate that to get minus 3, and there's no value outside here. So my vertex will be minus 3 is 0. And then if I indicate it on the graph, I'll get this, and I'll draw my V shape with this point as vertex. But I need to get this point. So this occurs when x is 0. So if I put x equals 0 here, minus 2 times 0 is 0. So what's inside the modulo sign is minus 6. The modulus of minus 6 is 6. That means the y-intercept is 0, 6. And then indicating on the graph, and you get that. Again, this graph and this graph are the same. And it's because of this analysis here once again. So we started with this one here and ended with this, which is the same as that, and hence the same as that. And this is the main reason why I chose these examples, just to show you that sometimes different modulus functions can end up with the same graph. Now let's go and do some more examples for practice. So first one, I've got y is equals to 3 minus 2x, with 3 minus 2x in the modulus sign. So for the sketch and reflect method, I've got my axis drawn, and I've got this to deal with. If I remove the modulo sign, I'm going to get y is equals to minus 2x plus 3. And that means I need to sketch this curve, which has a negative gradient and a y-intercept of 3. The x-intercept will be 3 over 2. And so I can go ahead and sketch this curve to get the following, where the y-intercept is 3, as we saw earlier, and then the x-intercept is 3 over 2. But this part of the graph has negative y values. It's not acceptable. So we reflect it in the x-axis, and we get this. And that is our sketch. For the vertex method, again, I've got my axis, and I've got this graph to deal with. And this, note that is the same as that. I've just rewritten it as follows for convenience. And I'll bring 2 out, not minus 2. 2 out. If I bring minus 2 out, I change the whole equation. So 2 comes out, and I'll get 2. I've got minus x here, and plus 1.5, which is 3 over 2 over here. Then, because I want the coefficient of x to be positive, I can factorize minus 1 out inside the modulo sign to get the following. But we know that the modulo sign will convert the negative to be positive, and so we can get this. Now that the coefficient of x is positive, I can negate it, which will be 1.5. The value outside there is 0, so my vectors is 1.50. So I'll indicate that on the graph, and then use that as my vectors to draw my V shape, and I'll get that. But we need now to find the value of the y-intercept. And for the y-intercept, if I put x equals to 0 over here, minus 2 times 0 is 0. So I'll be left with 3 in the modulo sign. The modulus of 3 is 3, and that means the y-intercept is 0, 3, and then I'll indicate it appropriately on the graph. Next question, I have y equals to minus 3x plus 1. This time the negative is outside the modulo sign, and that means this graph will be a different shape from this, as we saw earlier. So I've got my axis, then I've got this to deal with. Y is equal to negative the modulus of 3x plus 1. And so if I expand the negative into the modulo sign, I'm going to get minus 3x minus 1. And that means I need to sketch this curve here, I've got a negative gradient and a y-intercept of -1. And then x-intercept will be -1/3. So I can sketch the graph now to get the following, where the y-intercept is -1 and the x-intercept will be -1/3 as we found earlier. But now we have got a situation where the y values must not be positive because of the negative sign outside here. So whatever we have here will turn out to be positive. No matter what value we have inside here, it will turn out to be positive because of the modulo sign. So when we negate that positive, we get a negative value. So this graph must not have positive values for y. And that's why this part of the curve must be reflected in the x-axis. And then when we do that, we're going to get this. And that is our curve. So please know that whenever you have a negative sign outside the modulo sign, the curve will have this nature. Now let's use the vectors method for this particular question. So I've got my axis and I've got this to deal with. So 3, I can bring 3 out. Remember, we need to bring positive values out. So if I bring 3 out, I have x left here and plus 1/3 over there. Now here, the coefficient of x is positive 1. And so I can negate this and get -1/3 as x coordinate. There's nothing outside here. So the y coordinate will be 0. And so my vertex will be -1/3, 0. So I'll indicate that on the curve. And because of the nature of the curve with negative outside here, I'll draw this as my vectors, but this time the other way around. And I'm going to get the following. Now we must find the y-intercept. And y-intercept occurs when x is 0. So when x equals to 0, 3 times 0 is 0. 0 plus 1 is 1. The modulus of 1 is 1. Negate it, you get -1. That's why the y-intercept is 0 minus 1. And then we indicate it on the graph. We get the following. The next question. I've got y is equal to minus outside the modulo sign. Then I have 2x minus 8 inside the modulo sign. So I've got my axis drawn. Then I've got this to deal with. If I expand the negative into the modulo sign and remove the modulo sign, I'm going to get minus 2x plus 8. So I'm now going to sketch this curve here. And we can see that the y-intercept is 8. It has got a negative gradient. And the x-intercept is 4. So we can sketch it appropriately as follows. Where y-intercept is 8, like we said, and x-intercept is 4. Because of the negative sign outside here, the y values must not be positive. And so we can reflect this dash part in the x-axis. That means the intercept over here will be minus 8. So I get that. And then I have minus 8 over here. Using the vertex method, I've got my axis and I've got this question to deal with. If I bring 2 out, I have x here and minus 4 over there. Now that the coefficient of x is positive 1, I can negate that to get 4. And there's nothing outside here, so that will be 0. So my vertex will be 4, 0. And so if I indicate it on the graph, I have 4, 0 over here. But again, because of the negative sign outside here, my V-shaped will be drawn the other way around as follows. Next, we determine the y-intercept over here, and that occurs when x equals to 0. So when x equals to 0, 2 times 0 is 0. 0 minus 8 is minus 8. The modulus of minus 8 is 8. Negate that, you get negative 8, and that's why the y-intercept is 0 minus 8, and then we put it on the curve. The last question, y is equal to half x plus 3 inside the modulo sign. So I've got my axis drawn, and then I'm going to remove once again the modulo sign. So this curve here has got a positive gradient, y-intercept of 3, and an x-intercept of minus 6. So I can sketch my curve appropriately. Y-intercept is 3, x-intercept is minus 6. And here, because the sign outside, the modulo sign is positive, and so that means this part must be reflected in the x-axis. and I'll get this. And that is the curve required for this curve using the sketch and reflect method. And then for the vertex method, I've got this to deal with. Half x plus 3 in the modulo sign. The coefficient of x is not 1, as you can see, so half must come out. So if I do that, I'm going to get this. Now that x has a coefficient of positive 1, I can negate 6 to get minus 6. There's nothing outside here, so my vertex will be minus 6, 0. So I'll indicate that on the graph, and I draw a V shape with that as my vertex. Again, taking into consideration the fact that the sign outside the modulo sign is positive. So we have that. And finally, we need to find the y-intercept. So when x is 0, I'm left with 3 inside the modulo sign. The modulus of 3 is 3. So my y-intercept is 0, 3. And then finally, indicate it on the curve to get this. So this is how you sketch modulus functions. And with this last example, we come to the end of this session on sketching of modulus function. Thank you for watching. See you in the next video.